Okay, we have all this information here. We don't need to look through all of it right now, but it says a political pundit on TV claims that a majority of independents oppose the healthcare public option plan. Majority. Majority means greater than 50%, right? That's the majority. So, do these data provide strong evidence to support this statement? So, we're trying to show this. So, of these three options, the only one that's trying to show that is the second. They're saying it is 50. He's saying it's greater than 50%, the majority. So, that's where you get that answer from. So, now we're going to run a hypothesis test. This is on a proportion. So, when I go to stat over to my tests, I'm going to do a one prop z test. Whenever you're talking about proportions, you want to do a one prop z test. So now it says, what's the null proportion? That's 50%. And it wants a number out of the total number of people we're talking about. We're talking about independents. So there were 783 independents surveyed. So that's going to be N, 783. And then it says independents divide 52% against, 42% in favor. So we're trying to figure out what percent oppose. So what percent of our sample oppose? So that's 52%. So I need to know what that number is. So if 52% of 783 times 52%, that's 407 people. Okay, you round this, don't always round this up. It's not a sample size. This is just going to be 407 people out of 783 gives us 52%. So we'll go back to our stat. Stat one prop z test. I just forgot the number. 407. Okay. One prop z test. So of 783, 407 satisfied this thing we're talking about here. And we're trying to show that our alternative is greater than that. And now we hit calculate. So we get a p-value of 0.13396, or to 4 decimal places will be 1.1340. So that's what happened there on question 1. Okay, this is question 5. All your numbers look good. Your p-value is less than or equal to alpha. Alpha is 0.02. This is less than 0.02. Something you want to remember that I tell people in person is if p is low, reject HO. If p is low, reject HO. So since p is less than alpha, we are going to reject the null. Reject HO. Okay, so since we reject the null, which is saying it's equal to 57.2, we can accept that it's not equal to 57.2. So let's see. There is sufficient evidence to warrant the rejection of the claim that the population... No, that's a double negative, and that's not right. There is not sufficient evidence to warrant the rejection of the claim that the mean population is not equal. The sample data support the claim that the population mean is not equal to 57.2. That's the alternative. So we can get rid of all those guys. So just remember that. If the p is low, lower than alpha, we reject HO. And the last one, number 6, says you're conducting a study to see if the probability of a true negative on a test for a certain cancer is significantly less than 63%. Use a significance level of alpha equals 0.02. So the null is that it's equal to 63, and we're trying to prove that it's less than 63. So we obtain a sample of 389. So I'm going to go to stat over to one prop z test. We were trying to show that it's less than 0.63. So there's our null, is that it is 0.63. The number of successes is 216 out of 389. And we're trying to show that it's less than. And we hit calculate. So we get a test statistic of negative 3.053. And we get a p-value of 0.0011. I'm not sure what happened here, but those are going to be your correct answers.